Okay, chapter 20, day 1 video. Today in class we learned about hypothesis testing by selecting the pennies out of the bag and measuring the proportion that we got compared to what the U.S. Mint claims. And here's the general notes that we need then for hypothesis tests for proportions. So chapter 20, day 1 is about hypothesis tests for proportions. A hypothesis test is when you make a hypothesis about something and then you try to see if your results have enough evidence to either reject that hypothesis or not enough evidence to reject the hypothesis. So we let H sub 0 be the null hypothesis. And the null hypothesis is that the true proportion is always equal to some claim that someone makes. Like the U.S. Mint claims that the proportion of pennies from the 90s, let's say, is 0.3. Then the true proportion would equal 0.3. So this P sub 0 is just some number. So the true proportion is some value. This is just some value. This will be a decimal. The true proportion is some decimal. The alternative hypothesis actually has 3 options. One option might be that the true proportion is greater than that initial null value. The one that we did in class, the true proportion is less than that initial null value. You know, we said is our percentage of pennies less than what the U.S. Mint claims. Okay? This last option, the true proportion, is purely different than. And this last option really is when you're not sure if your data is going to be higher or lower, and you're concerned if it's high or low, I want to know if it's different than what we started with, then we use a not equal to option. I don't know if it's going to be higher or lower, but it's just going to be different than. These graphs, you can draw them, but I'll explain them more when we get back to class. So I have 3 alternatives. You're only going to use one of them when you do the problem, but here's your choices: greater than, less than, or different than. The null will always be that it's equal to some value. Okay? So we ran the test in class, and we calculated a z-score, and we had an answer, and we talked about p-value. And I said I would give you more of a general description of p-value. Well, here's the meaning of p-value. If the null hypothesis was really true, and that you always have to state, if the null that they claim was really true, then the p-value, it is the probability of getting our data, the probability of getting our results that we got purely due to chance, or sometimes they call it natural selection or natural variability. So that's the p-value meaning. If the null was really true, it's the probability of getting our results by chance. And we talked about that in class. Now, in order to do the problem, we need to talk about standard error again for proportions. And the standard error is going to be, and you can just leave this off for now. But the standard error is P sub 0, or the initial claim, because that's what's true until we can prove otherwise, 1 minus that over n. After we check our conditions, we know that we can use z, which is p hat minus p sub 0 over se. That's our z formula that we'll end up using. Our data proportion from our data minus the claimed initial hypothesized proportion over se. In class, we talked about the conditions necessary for this to happen. Again, you need randomization or representative sample. We need independence, as well as the population being greater than 10 times the sample size. And we're going to check n times p, but again, we're using that initial hypothesized p sub 0 value, like what the U.S. Mint claimed on their pennies. Because that's what's true until we know otherwise. If we meet all these conditions, then we state, in general, that it is okay to do a 1 proportion z test. Because we have 1 proportion, because that's our data is just a single proportion. Z, because we're still using z-scores. And we're doing a test. So in general, steps for a hypothesis test. You know, what are the pieces and the parts? Well, first you're always going to have to list your HO and your HA, just like we did in our class problem. You got to check your conditions to make sure that you can use the formulas. Calculate your Z, and then find your p-value, which is the proportion from the back of the book, or we're going to use our calculator nowadays, and the conclusion. Okay? Using the calculator, you're going to go stat, test, and then the option was number 5, stat test 5, which was 1 proportion Z test. And then it says P sub 0, which is your null hypothesis. It says X, which is the number of successes. And remember, that cannot be a decimal. So if they give you a percentage of the total, you have to round it and make it a decimal, or make it a whole number. N is the sample size. And then you have to pick the right alternative and then hit calculate. Okay? Conclusion. We wrote this conclusion, but here's a general formula or format with that. We always talk about the p-value. So with a p-value of blank, write down your p-value. That's the probability you got from the shaded part of your normal curve, which is, then it's either going to be less than or greater than. Either your p-value is less than or it's greater than the rule of thumb alpha equal to 0.05. Well, if it's less, we are going to reject the null hypothesis. We have evidence. If it's greater than, then it's not significant. So if it's greater than, we fail to reject. Okay? The null hypothesis. So if it's less, we will reject. There is enough evidence. All right? There does appear to be enough evidence. If it's greater than, we fail to reject. There's not enough. There's not appear to be enough evidence. That, and then whatever the alternative hypothesis is. So for us, we said that the proportion of pennies from the 1990s is, you know, less than 30%, or whatever we had in class. So, in general, if there is less, we will reject. There is enough. There does appear to be enough. If it's greater than, we fail to reject. Not enough. And so, what I do at the end is something to remember. If you can remember less, reject, enough, LRE, less, reject, enough, then it will help you with not less, not reject, not enough. Just kind of helps you through that process. And that's it. I mean, when we come to class, next class we're going to work on some problems in class in which we will do hypothesis tests. We will have to write conclusions, and we will also have to talk about p-value and context. All right, that's it.